Alright guys, how are we doing today? I'm actually going to turn this down just a little bit. Okay, so we dealt with probability on a basic level. Now we're going to get into probability of compound events. And I apologize if I go a little fast. I am in the rush to get out of here so I can get to golf practice. Make sure that if I do go a little fast, you use the rewind and the pause button a lot and get this down and get it correct, okay? So for compound probability, there's a few new definitions you're going to need to know. First one is a compound event, and that is two or more events linked by the word and or the word or, okay? So it could be something like the probability of 3 or 4, okay? Or it could be the probability of 3 and 4. Mutually exclusive events is when two events have no outcomes in common, okay? So I guess you could say, for example, I roll a dice and I pick a color, okay? And I'm looking for what's the probability that I'm going to roll a 2 and I'm going to get the color blue, okay? Those events, their outcomes are going to have nothing in common. All right, but we could be looking for the probability of those together, and we'll see how to do that in a minute. Overlapping events is when events have at least one outcome in common, okay, which kind of makes sense. And then you have independent events, is the occurrence of one event does not affect the probability of the second event, all right? And then you have dependent events, which is the occurrence of one event affects the probability of the second event. Now, if it's independent events, to find the probability of A and B, then you do the probability of A times the probability of B. Okay? That's for independent events. Now, if they're dependent events, so the occurrence of the first event affects the probability of the second. Okay, so then you have the probability of A, then B. That's going to be the probability of A times the probability of B after A. All right? So that's probably not going to make a whole lot of sense yet, but let's actually get to some problems, okay? So the first problem says, suppose you spin a spinner that has 20 equal sized sections numbered from 1 to 20. What is the probability that you spin a 2 or a 5? Okay, so this is saying that you spin a 2 or a 5. Now let me ask, if I spin a 2, does that affect the probability of me spinning a 5, or is the probability still going to be the same? The answer to that is that it's still going to be the same. Okay, so these are independent events, and they're also mutually exclusive. Okay, so what you're going to do here then is you're going to say the probability of 2 or 5, which I can write then as the probability of 2 times, plus the probability of 5. And I actually apologize. I should have wrote a few more things down here. So the probability of mutually exclusive events is the probability of A or B is going to be the probability of A plus the probability of B. Okay? And then the probability of overlapping events, so this is the probability of A or B, is going to be the probability of A plus the probability of B minus the probability of A and B. Okay? And we'll get into this in a minute here. Okay, so these are mutually exclusive because when I Because the spinner cannot land on 2 and on 5, that makes these mutually exclusive, okay? So we're going to say that the probability of 2 plus the probability of 5, all right? So when I find the probability of 2, okay, the total possible outcomes is 20, and I only have 1, 2 in 20, so that's a 1, okay? The probability of 5, all right, possible outcomes is 20, and there is only one number 5 in 20, so I'm going to put a 1. So now we're going to add the two together, because it goes to here, plus 1 over 20. This is going to give me, when I add fractions, denominator stays the same. Add the numerator, and then I can simplify this to 1 over 10. Okay? So this is how you would do a mutually exclusive event. Now, let me show you one that is going to be overlapping. Okay? Actually, I will skip that and I will do an overlapping one tomorrow. Okay? Example number 2 says, suppose you roll a red number, cube, and a blue number, cube. What is the probability that you will roll a 3 on the red cube and an even number on the blue cube? Okay? So, now this one isn't going to be mutually exclusive or overlapping. What we're looking at here now is this independent or is this dependent probability? Okay? Or events. So when I look at the red cube, does the probability of me rolling a 3 on the red cube, does that affect whether or not I'm going to be able to roll an even number on the blue cube? No. Okay? They're completely separate. I'm rolling a red cube. Whatever happens on that red cube is going to happen regardless of what happens on the blue cube. Okay? So, because that's the case, these are independent events, which means that the probability of A the probability of, not even A here, we're looking for the probability of red 3, okay, and so I'm looking for a red 3 and blue even, okay? So this is what I'm looking for. I'm looking to get a red 3 and I'm looking to get blue even, all right? Because of this, because they're independent, that means the probability of A and B is going to equal the probability of A times the probability of B. Okay? So, remember, the cubes, just like a dice, they have 6 sides, or 6 numbers. Alright? So, the thing we got to look at then is on the red cube, what is the probability that I'm going to get a 3? Alright? Well, there is 1 3 on a 6-sided dice, and there are 6 chances. Alright? Now, the probability that I'm going to get blue on the blue is even. There are 6 numbers, and how many of them are even? Okay? You've got 2, you got 4, and you have 6. So you have 3/6. Alright? Now I'm going to take these events and I'm going to multiply them together. Alright? So I have the probability of red 3 and blue even is going to equal 1/6 times 3/6 is 1/2. This is going to be 1 over 12. Okay? Which is going to be my answer then. Alright? If I wouldn't have simplified, it would have been 1 times 3 is 3, 6 times 6 is 32. 3 divided by 32 is going to be 1 over 12. Okay? So this is how you would do independent. Alright? So now let's look at this. You have 1 freshman, you have 2 sophomores, 4 juniors, and 5 seniors. receive top scores in a school essay contest. To choose which 2 students will read their essays at the town fair, 2 names are chosen at random from a hat. What is the probability that a junior and a senior, a junior then a senior are chosen? Okay? Now, when I put these names into a hat and I pull one out, all right, I'm not going to put, okay, so let's say that we pull that junior out. Let's say his name is Bob. I'm not going to put Bob back in the hat to have him chosen again, okay? So, the probability that the very first time I get a junior, okay, let's find that first. So I have 1 freshman, 2 sophomores, 4 juniors, that's 7, and 5 seniors puts me at 12. So the total number possible when I pull the first one out is 12. Okay? Now, when I pull that out, what is the chances? So how many juniors are in there? Well, there's going to be 4. So this is, before I simplify this, okay, so this is 4 out of 12. Now, my probability that I'm going to get a senior next, let's check this out, okay? So I pull one out, so now how many do I have left in? Well, if I had 12 and I pull one out, that means I only have 11 left in, okay? And how many of them are seniors is 5. Okay, so this can't be simplified. So this is what we call probability of dependent events, okay? Because the probability of this one changed because I took one out in the first one, all right? So this first one affected the probability of the second. So these are dependent events. Now I'm going to simplify 4 over 12, which is going to be 1 over 3, okay? Now, we're going to do the probability of A. Okay, so we're going to do the probability of J, then S, is the probability of A, which is the junior, so that's 1/3, times the probability of getting a senior after I took out A, so that's 5 over 11, which is going to be 5 over 33. Okay? Let me just double check my answer here. Okay, so that is correct. All right? So this is what we call dependent probability. There's also one other thing that I'm going to go over a little bit more tomorrow. This is what we call dependent probability without replacement. All right? Which basically means that when I took the junior out here, when I took them out, I didn't put them back in. So that's without replacement. Okay? And that's why this changes. All right? So make sure you write down any questions. I will be doing a few more examples of some other type of problems to go with this tomorrow, and there will be a worksheet. So come tomorrow ready to work hard because I'm going to need it tomorrow. Okay, guys? I gave you a light day today. Let's make up for it tomorrow. Have a great night tonight, and I will see you guys tomorrow morning and afternoon.